I'll just give my quick little spiel about Wisconsin Land and Water prior to the formal intros of our presentation here. So hello, everyone, as you're joining in this afternoon. We're at the lunch hour now. Thank you for joining us today. My name is Kelly. I'm from Wisconsin Land and Water, a 501c3 that supports the efforts of land conservation departments and committees throughout the state in a variety of ways, including helping to host trainings and events like this one. So just before we officially begin today, I just want to let everyone know that the webinar is being recorded and it will be posted on the Wisconsin Land and Water website. So I'll send an email out to everyone once the recording is available online. And if there are anything that our panelists want to share, any links or anything like that, I can include that on the email as well. And we will take questions today via the chat function or the Q&A function. So there should be, like at the bottom of your screen, a Q&A to submit. Otherwise, everyone is also welcome to use the Zoom chat to input any questions that you have today. Feel free to submit them at any time, and we'll try to address as many as we can at the end of the presentation today. So today's presentation, A Salty Situation, is presented by Allison Madison and Laura Herrick. Allison is program manager for Wisconsin Saltwise. And since assuming her role in June of 2020, she has spearheaded collaboration around salt reduction in watersheds across the state. Her work takes her to mall parking lots, urban streams, county highway shops, and the Capitol building. Allison has 10+ years of experience in science and sustainability education in both formal classrooms and national parks. She graduated from St. Olaf College and has a joint MS in Environment and Resources and Soil Science from the University of Wisconsin. She's passionate about protecting Wisconsin's freshwater resources and celebrating their beauty by paddling, swimming, cross-country skiing, etc. And Laura, in her role as the Chief Environmental Engineer for the Southeastern Wisconsin Regional Planning Commission, manages a staff of 7 with specialties in engineering, planning, and biology. She has 29 years of experience in the water resources field, specializing in hydrologic and hydraulic modeling, water resources engineering, water quality analysis, and floodplain and stormwater management. Prior to joining the commission in 2008, she worked as water resources project manager for consulting firms HDR Engineering and CDM Incorporated. She received her BSCE degree from Valparaiso University and MS in Civil Engineering from the University of Minnesota. And she is a registered professional engineer in Wisconsin and a certified floodplain manager. So with that, I will turn things over to Allison to kick us off today.
All right. Thank you for that introduction. Thank you, everybody, for joining in this morning, well, afternoon, I guess, over your lunch hour. So I'm going to take about 20 minutes today to give some background on Wisconsin Saltwise, the problems with salt pollution in our lakes, streams, and drinking water, which is really the heart of Wisconsin Saltwise work, raising awareness around that, as well as working to find solutions and showcase the incredible stories that we have going on around the state. So I'm happy to be with you today to share some of those. So Saltwise is a coalition of organizations working across Wisconsin. You'll see here the logos of our funding partners, with most of our funding coming from the Fund for Lake Michigan. So thank you to all of them. To talk about salt, I want to just give a little primer here. I used to be a high school chemistry teacher, so please bear with me. But typically when we're talking about salt, we're talking about sodium chloride. And those ions, sodium and chloride ions, hang out together. But when we introduce them to water molecules, which also really like to hang out together, they find new friends. So water molecules will grab a hold of sodium and chloride and dissolve that salt. And in the winter, we find that to be really beneficial, right? We want to melt snow and ice. So get those water molecules to let go of one another. That is melting. But in the process, we create salt water. And that can cause some issues, which I'll get into. So since today's talk and the week today, our week focus is on stormwater pollution, primarily going to be discussing winter road salt. So that is the #1 source of salt pollution in Wisconsin. We put that salt down on pavements, whether it be roads, highways, sidewalks, melts the snow and ice, and it seems to disappear, but we know it doesn't, right? It moves without water through storm sewers into lake streams, sometimes finding its way into our drinking water. But there are other sources of salt. Those are water softener salt, and I made a little addition to this sign here. I think we should have some education near areas where we are selling salt, whether it be road salt or water softener salt, reminding people that all is going into our fresh water. And there are also chloride-based fertilizers, be another source from agricultural fields, as well as potentially your home lawn. So take a look and see if you've got some salt, some chlorides in your fertilizers. Like I said, road salt is the primary source of the salt that is showing up in our drinking water, lakes and streams across Wisconsin. So that is the same salt that you put on your French fries or maybe your eggs this morning, sodium chloride. The big difference is when we're putting some salt on our food, we're usually using teaspoons be the appropriate unit for that. When we talk about salt going down on our roads, we are using tons of salt. And if we look at this graph to the right, we're actually talking about millions of tons of salt that are going down across the US every year. Now, if we look at just Wisconsin, we don't have the best data. We've got some pretty solid numbers for what's happening on our state highway systems. And also the DNR does require larger municipalities to share information about what's going down on our streets. But we don't really know, on the private side, I was going to ask you, how many cups or pounds of salt did you put down last winter? Trying to get that data can be a little tricky from everybody that is putting salt down. So I feel pretty solid to say we're roughly between like 1 and 2 million tons of salt a year going down each winter. And like I said, we don't really track that too much. Salt does some good. People see the benefit of salt and tend to overlook the damage that it does. So I took a picture here trying to highlight some of that damage and highlight some of that overuse. The sidewalk to the left, that's not snow, that's actually piles of salt that you're seeing there. So that makes me pretty sad because, my work puts me in touch with all of the damage, the pretty heavy toll that salt is taking on our vegetation, on our infrastructure, roads, bridges, our vehicles. So in total, if we kind of add up all the damage that salt does, it's about $10 of damage to every dollar that we spend on salt. And that's before we look at the damage that salt does in our freshwater ecosystems. So what you're looking at right here on the right is obviously a map of Wisconsin with a whole bunch of data points that are averages from many decades of data. So I think the earliest data point in here is coming from like the 1960s. So it's been any data points that we have in freshwater lakes and streams averaged together. So this isn't what's happening right now, but it's kind of the full data set that we have available. A couple things to look at or that maybe pop out at you, right? Those brighter colors, the greens and yellows. So naturally in Wisconsin, we do have really fresh water. Chloride levels would be in the dark blue here, 0 to 10 milligrams per liter across the state, but we see that's not the case anymore, especially in southern and southeastern Wisconsin, where we have the highest populations, the highest number of vehicles, and the most pavement means the most salt going down. So the Milwaukee area, Madison area, Fox Valley, we do see kind of a chloride plume here, like a spike coming out of Marshfield. This is actually Mill Creek, which receives a lot of salt, water softener salt from their wastewater treatment plant. So like I said, road salt's not the only contributor here, but it is the primary one, which we'll see in some more data coming up. So naturally, pretty low levels of chloride. These are the current values right now that the DNR has set to say when freshwater organisms are going to be stressed and die from high chloride. But we definitely see significant impacts to ecosystems at values much below that. So around 50 milligrams per liter is where a number of ecologists that are studying the composition of freshwater communities and streams see that different species tend to not survive, not be able to deal with that stress of salt on their system anymore. So we can look at this, geographically across the state. I think it's also really useful to look at it temporally. We don't have really rich data sets across Wisconsin, but we do in the Madison area, where we have our flagship university and lots of researchers who've been doing work for decades. So this kind of shows us over time that pretty steady increase in chloride concentrations, chloride milligrams per liter, since the city of Madison allowed salting on residential streets throughout the city. Private contractors, individual homeowners, right, all contribute to this salt problem. So I don't want to steal Laura's thunder, but I do want to show one other pattern that we see, and that is the seasonal spikes in, again, we have chloride levels here, now going not into just the hundreds, but into the thousands of milligrams per liter. So in southeastern Wisconsin, also in the Madison area, where we have some better data collection that has happened or currently set up, we're catching some of those spikes into the thousands of milligrams per liter of chloride that tends to happen during warmer days in the winter when we have that really salty snowmelt rushing into streams. So who cares? Chloride numbers, what do they mean? This is what we see real world and in lab studies. So this is work from Bill Hintz's lab at the University of Toledo, where they take different organisms and see how that's the stress of those high salt concentrations impact them. So they measure decreased rates of growth, decreased rates of reproduction, increased susceptibility to parasites. This is around 1,000 milligrams per liter of chloride, but like I said, that 50 milligrams per liter is where we start to see impacts in some smaller organisms, tiny little zooplankton that play a really important role in the food chain. So as their populations go down, that means less food going up the food chain. They also eat algae. So as their populations go down, the water tends to get greener and murkier. So this bucket is, again, from Bill Hintz's work, where they take buckets of stream water and increase the concentrations of salt and just see that decreased water quality as it gets saltier. Kind of worst case scenario is our lakes being unable to undergo that natural seasonal turnover. And we see that there's a lake in Minneapolis, Brownie Lake, lake here in upstate New York, that have gotten so salty. And since salt water coming in is more dense than fresh water, it can create a cool, salty layer at the bottom of lakes that's resistant to that natural flipping that is needed to cycle nutrients and oxygen throughout the lake. Finally, we're looking here at what's happening to our drinking water. So most people in Wisconsin do drink groundwater. Not everybody. Some folks, especially in the Milwaukee area, are drinking Lake Michigan water. But if we look at our public drinking water wells, our groundwater wells, we are also seeing chloride levels steadily increase. So this is a map put together by the DNR. If you want to get more information, you can check out their 2022 statewide chloride strategy report. But these are wells across the state that have exceeded the preventative action limit for chloride. Again, kind of moving to that worst case scenario, which we've gotten to in upstate New York. This is a clip from a webinar that was presented during Salt Awareness Week earlier this year. So there are a number of families in upstate New York that can no longer drink their own well water. And this is a family that has had to actually sell off their dairy herd because while they are drinking bottled water, they can't buy bottled water for all of the cows. And so this multi-generational farm went out of business. There's also some research that recently has looked at how salt can mobilize other ions that are present in soils and our bedrock and in pipes. So the lead crisis in Flint, Michigan, people may or may not know, was exacerbated by the fact that they were drawing salty water from the Flint River, caused more lead to be released from pipes. This is the work of Sujay Kaushal and his team in Maryland, trying to understand why in the spring in the DC area, water was coming up very rich in manganese. It was that ion exchange with the high salt that had moved into the water that winter. So a lot of numbers to throw at you there. Trying to use terms that may be a little bit more familiar with people. It takes 1 teaspoon of salt to pollute 5 gallons of water. And I've underlined permanently pollute because once that salt goes in, it's really hard to take it out. It's technically possible, but not really feasible. So rain gardens, green infrastructure does not filter salt out. And even our wastewater treatment plants are, they're not designed to remove salt, and adding the technologies to do that would cause the sewerage rates to just soar and be astronomical, a lot of energy to do that, and that means greenhouse gas emissions. So again, not really practical. So I just gave you a lot of bad news, but I'm going to switch it up here and share some good news, some great stories about what's happening around the state. So I'm going to start with education. If we want to see changes happening with how we use salt, we got to make sure people, understand that overusing it is a problem, and 2, what are the solutions? What can we be doing? And thankfully, there are a lot of different ways that we can make changes to practices to reduce salt use and overuse. So these are some of the classes, free classes and workshops that we have going on across the state this fall. In addition, there are a number of agency trainings happening as well. And there are resources on our website, different print materials, webinars I'll get into in just a second, equipment open houses, which are really great events to bring together winter maintenance professionals, either on the roadside, parking lots and sidewalk side, to talk about best practices, share equipment successes or pain points they've had, and work through those together. So we try to always get the media to those events to share those best practices and stories and build the networks that can support people to be successful. So I mentioned webinars. A lot of those webinars are those success stories that we see. And you can see here a lot of municipalities around the state, which is awesome. I also am highlighting the Salt Watch Community Science Initiative that is put together by the Isaac Walton League. So anybody around the state can ask for some free test strips, and you can help support data gathering that is kind of the foundation of a lot of the advocacy work that the Isaac Walton League does around this issue. So I mentioned that there are a lot of things that can be done differently. And so in all of our classes, we are promoting best management practices that you see illustrated here. And I'm gonna just touch on a couple of them. Our classes are multiple hours long, getting into the nitty gritty. But if you're not working in this field, you might be a little much. So I'm going to kind of give you the high level view, some big wins that we see, the low hanging fruit. So calibration is one of them. All the equipment can be calibrated. There's no additional cost here. There's a little bit of time. We have resources to support this online. People can email me. I'm happy to make connections for you, potentially even come to your agency shop if that would be helpful. But Cudahy here, it's just south of Milwaukee, had a great story to share a number of years ago when they started to calibrate. They took some awesome pictures. They showed us that before they calibrated their trucks, one of them, at least here, it was supposed to be putting down 300 pounds a lane mile. It was putting down 850 pounds a lane mile. So they calibrated it down to put 300 when they wanted to put down 300. And that's a savings, huge savings, right? In salt, the cost of that, the damage that extra salt was doing, all that salt ending up in our water. They were able to keep those dollars as salt savings in their department and make some investments in their equipment, which isn't always possible, but they pulled some strings and that helped them make some upgrades to equipment. They started using brine and they further reduced their salt use in following years. Photographed here is a picture from inside the cab of a Stevens Point truck. And I'm circling their little cheat sheet for drivers. So this is showing off that they are pre-wetting their salt with salt brine, which is the best practice that helps salt. That wetting it helps it stick in place, reduces bounce and scatter, keeps salt in the roadways where we need the melting to happen, and also activates the salt so it works faster. We see here that at high temperatures, 30 degrees or above, 30, 31, they can put salt down at rates as low as 120 pounds per lane mile. Moving on down, because as it gets colder, salt doesn't work as effectively. Below 15, where salt really is not effective as straight salt, they're putting an additive in. So happy to talk more about any of those kind of concepts that I'm highlighting. But again, Stevens Point's numbers kind of show the real impact. Before calibrating, average salt use was 4,500 tons a year. Making changes with calibration, using ground speed control, it's about 2/3 reduction in salt use, just incredible. So those stories that I had on the public side, I want to share, on the private side, there again is a lot of opportunity, but we have an additional barrier, that fear of liability. So if you're familiar with this world of salt use, probably are aware that New Hampshire has incredible legislation, started a program 10 years ago now to provide limited liability protection to contractors. We tried last session. We did introduce a bill to create a similar program in Wisconsin. A lot of lobbying efforts there, lots of great conversations. In the end, I've got the governor's veto message up here. It was too challenging to kind of overcome concerns of the trial lawyers that, I won't speak too much about the politics of this, but we hit a dead end. So trying to understand, can we come back and work on this again this session? There's also opportunity, my next slide here, to potentially look at modeling a new program off of what the H2 Ohio program did just recently, which was to create some grants to support municipalities to make upgrades to equipment. So this is kind of a pivot, but potentially might have an easier path forward. So Ohio actually has distributed that 1.7 million, and there was so much need, they put out another 2.7 million in the just recently the last few months. So I think they've distributed over $4 million in 2024. Moving away from kind of politics, like more of like a bottom up, I think one of the really key things that needs to happen is more people need to be talking about salt and understanding this is an issue for us to make that change. So we've got a lot of volunteers across the state that have helped out and spread the word in a variety of ways. Here are some signs: shovel more, salt less. Like, this is taking that best management practice at the, that's true for highway departments, and bringing it down to kind of the personal level, what you can do, like maximizing that mechanical removal. The more that you shovel, the less salt you have to put down, and still have safe pavement. We have resources for teachers. If you have any teachers in your networks, pointing them to these lessons would be great. We also do projects with municipalities across the state, highlighting here the city of Madison, naming their snowplows. The back of little trading cards for each snowplow, they've got some salt-wise facts. We tried earlier to play this video, it didn't work super well, so I think we're just going to put the URL in the chat for you, but really powerful PSA we worked on with the city of Milwaukee. And then the last thing I would mention here is Salt Awareness Week. So similar to Wisconsin Stormwater Week, we had a Wisconsin Salt Awareness Week that's grown. We've lost to Wisconsin because we're now sharing this week with a number of states across the Midwest and the East. So this is a week that we have the end of January each year, and try to get as many organizations and municipalities involved to talk about what they're doing around salt use and what reduction solutions are working in their communities. So last kind of thoughts for you would be to think about how you can spread the salt-wise message. I'd say you're doing something right now. You're educating yourself by joining this webinar, so thank you. Continuing to talk about things that you learned today with your friends and neighbors. Promoting Salt Awareness Week would be one easy thing. Mention kind of like easy collaborations to kind of do that. Following us on social media. Wisconsin Saltways is on Twitter. We're not on Twitter, excuse me. We're on Facebook and Instagram. It's a small thing, but that helps us continue to get grant dollars. So you stay informed and support our work that way. And you can easily share things. If you want to get more involved, I'm happy to help seed some more Shovel More Salt Less campaigns around the state. You can get, like I said, free test strips to do some monitoring on local streams, but just kind of keep us in the loop with what you're doing. It helps if we have more stories to share. And finally, if you would like to get a little bit more involved, changing some of the rules and the policies around salt, would love to add your voice to the Saltways team on that, and we have resources to make that as easy as possible. So with that, I think I'll turn it over to Laura, and I think we're gonna just wait till the end for any questions. So thank you.
All right, hopefully everyone can see my screen. All right, I'm just going to go ahead. Again, Laura Herrick, I'm the Chief Environmental Engineer at SEWRPC. I'm here today to talk about our chloride impact study. Let me get going. All right, so I want to give you a little bit about SEWRPC. It's going to be quick and dirty. Talk about our scope of the project and how it came to be. Spend some time on our monitoring work, and then spend bulk of the time hopefully on our analysis work and next steps for the project. So just where we are in the state, we're the southeastern corner, those 7 counties shown there. I find it always interesting that we're 35% of the state by population and by employment. So major cities being Milwaukee, Racine, Kenosha, Waukesha, and others. A little bit about SEWRPC. We were formed in 1960. We currently have about 65 staff, and 15 of them are environmental staff. We're not only the Regional Planning Commission, but we're also the designated area-wide water quality management planning agency from the DNR. So we do a variety of plans. I always say we do plans that extend beyond corporate limits. We do larger watershed plans, community type plans, and some of the plans you see there. So a little bit about getting into the chloride impact study. It's been a long road. Just giving you a little bit of the schedule. We started a prospectus way back in 2014 at the request of a few of our commissioners. That purpose of that was to develop our scope, schedule, and budget for the project and secure funding. We spent 3 winters, or 2017 to 2021, doing monitoring field work. Then analysis work really began in 2022. We are working with a technical advisory committee that was made up of public works staff, DNR, USGS. Many different entities are represented on that group to help us with, not only with the prospectus, but with the actual work. And I would be remiss, it's a significant effort for us, and significant funding came from the Federal Highway Administration as well as our own funds and the Fund for Lake Michigan, the Milwaukee Metropolitan Sewage District, and the DNR. So our study scope, this is the Cliff Notes version of the prospectus, and we've completed the items in red. So we have gathered conductance data for actually 41 stream locations and 6 lakes in the region over multiple winters, which was unique. We did not find a lot of especially stream monitoring data over winters, and that's something we really wanted to tackle with this study. We have also compiled existing data, not only our data, but historical data that we can find for our surface waters and groundwater throughout the region. That's also been a significant effort. And we have developed relationships between conductance and chloride levels. Since we're measuring conductance out in the field, and I'll talk a little bit more about why, we needed that relationship. Some other parts of our scope is looking at loads. So our hope is the loads we calculate in our stream monitoring locations, we can tie back to what's going on in the watershed. How much of that is really not only road salting, but private salting as well, parking lot salting, and how much of it might be water softening, how much of that might be agricultural fertilizers. So that's a big goal we're still working on now. We're also going to be looking at future conditions. The challenge there, we know we're the planning agency. We have a good feel for how we anticipate the region to grow and roadway systems to grow. Climate is a totally different animal. We're going to try and tackle that. How especially our winter is going to be different. Don't have as good a feel for that. We're supposed to be warmer, but does that mean more freezing rain conditions? Which could mean potentially we're salting just as much. The need to de-ice is still there. So that's going to be a little bit of a wild card that we're going to attempt to tackle. And finally, gathering state-of-the-art for that management of chloride for our various sources is another effort we're working on right now as well. So Allison's gone over this, so I'm not going to spend a lot of time. We're looking at all these sources. We feel the big boys are the ones highlighted in red. Road salt applications, de-icing in general, water softening, and that translates to our wastewater treatment plants, and then agricultural fertilizers. There are others, for example, cheese processing creates a lot of brine as well. So we are looking at those, but the main ones we feel are the ones highlighted in red. Want to talk a little bit about our monitoring work. We did, and on the next slide we'll list it. These are our field monitoring locations throughout the region. So the region is highlighted. You can see the 7 counties, and we did actually have to go up into the Milwaukee River watershed up out of the region in Sheboygan and Fond du Lac County because we were doing monitoring within the region. So each monitoring site is shown with the red star. You can see one of our goals was to have good coverage across the major watersheds, which are the different colors shown here in our region. Also good coverage across our counties. We definitely needed to do sampling where we had USGS flow monitoring going on because we need that for our loading analyses as well. A little bit more detail about the monitoring. The 41 stream sites, we started officially the first winter. 2017 was our pilot. Since we were going to be buying so much equipment, we needed to test some equipment to see what would work best. We learned that the chloride, direct measurement of chloride monitoring equipment wasn't very robust. It was very expensive and it didn't perform very well, especially through a winter. So we decided to go with conductance sampling, conductance measurement equipment. And we did continuous sampling for data every 5 minutes. So if you can imagine 2 full years with an additional 3rd year for event sampling every 5 minutes for 41 sites, it was a huge data set. The photo on the left shows you the above ground portion of the equipment. We had telemetry units shown there in white on the stake that we could watch back in the office. If you can imagine driving to 41 sites and trying to maintain them, it was really powerful to be able to watch everything back in the office, go, oh, our batteries tended to not do well in the winter. That was one of the concerns. So we were often replacing batteries in the winter. That was really helpful. And the right picture then shows the equipment portion in the stream. The cable down to the equipment is being held down by some concrete blocks to keep it along the bottom of the stream. And then the unit is actually cased inside of a PVC pipe, handmade, with holes in it, also zip tied to a concrete block. This worked really well. Kudos to all the staff that this survived the winters. We were really worried about it scouring out or getting pulled out by the ice. We didn't lose a single piece of equipment and it performed very well. Since we were measuring conductance out in the field, we needed chloride sampling as well. So we collected monthly grab samples at all the sites. And we added one extra winter, and I'll talk about why we did that. We needed some high, I call it event sampling, some high conductance times. We actually watched the equipment and ran out in the field quickly to gather during some high event times to fill out our data set. And then those samples were sent to the State Lab of Hygiene for the ions shown here, for the constituents shown here. We did also do lake sampling at 6 lakes in the region. They're shown here, highlighted, 2 in the north, 2 in the middle, and 2 in the southern part. Most of them are unfortunately in the Mississippi River watershed. That's just how our region works. But 2, Big Cedar Lake and Silver Lake, are actually in the Milwaukee River watershed, which contributes to Lake Michigan. So our goal there, this really came out of the worry that Allison talked about it, that chloride-laden water is accumulating at the bottom of our lakes and causing them to not fully turn over, which is important for getting oxygen to the upper levels and oxygen to the lower levels and nutrients to the upper levels of the lake. So we did profiles. We actually took samples at various depths at these lakes, at the deepest hole in each of these lakes. So we sampled them quarterly. And really, we did not see that accumulation at the bottom for these 6 lakes, at least. So that was good news. But we did see that Little Muskego Lake is shown right in the middle of your screen. In Southeastern Waukesha County, those levels are of concern. They're approaching that 250 milligrams per liter taste threshold put out by the EPA. So I'll show you some more data for Little Muskego Lake later on, but that was of concern out of our lake sampling effort. So I'm going to spend some time now on our analysis work. We have completed 4 technical reports, and I'm going to go through those as well as a few in progress. So our first technical report is TR61. Oh, I'm going to back up. So all this information can be found at our webpage shown at the bottom there. So you can either find it by that link or just go to our webpage. We just redid it. We're pretty happy about that. Under regional plans, and chloride study will be at the top. So TR61 was our field monitoring summary. So everything about our field work, how we set up our system, what equipment we used, how we did our sites, how we handled the data is all in this report. And it's pretty comprehensive. And that was our intent. It sounds like we have heard that CEWRPC, the Capital Area Regional Planning Commission, is using this as they do some similar field work. They're really using this technical report. So that makes us happy. One thing that is new for us that we're pretty happy with is how we show land use. This image on the right is the contributing land use to the Fox River site at Waukesha. So the sampling site, you can see there labeled Site 1. It's shown in as a pink star. And the contributing land use is all the color above it. Those colors match actually the graph on the lower part and its percentage of the watershed. So for example, the light yellow is lower density residential, and that's about 19% of the watershed. So we're starting to realize that not only does the overall land use matter to each monitoring site, but actually what's going on close to the site. also really matters. And here you can see we've got some high density residential and quite a bit of black, which is roads and parking lots near that site in particular, also is starting to be important as we're looking at the data. Our TR62, so Technical Report 62, was a huge literature review of the impacts of chloride salts. And actually, Allison did a great job describing quite a few of these. They're mentioned here again. Talked about the release of heavy metals is an impact of chloride in the environment, as well as impacts to infrastructure. But this is a huge literature review, really good foundation for all the impacts of chloride salts. I'm only going to spend a little more time on it. The effects on organisms. One thing I learned, I'm an engineer, is the where that critter is in its life cycle really matters for its impact. For its impacts from chloride. Is it in what I call infant stage or small, or is it fully developed? Does it live full time in water, or does part of its life cycle get out of water? That all mattered. And so this effort was led by one of our staff who's now retired, Joe Boxhorn. And Joe really, there's a lot of different information. He gathered as much as he could find on impacts of chloride to organisms. And finally, impacts to human health. It's actually more driven by the sodium piece of sodium chloride. And it's listed here, high blood pressure, osteoporosis, and then salts in the air can contribute to fine particulates, a factor in respiratory issues. So I'm not going to spend any more time on that. Please go look at that. That is a tremendous work. We're really happy with that as a foundational document of all the impacts of chloride. Switching gears on you, so we did do that regression analysis I had talked about, and trying to get from our conductance data we measured at 5 minutes to chloride levels. And this is actually for 30 of our sites. We came up with one relationship via 3 equations shown here. So these set of equations represent 30 of our sites, which we're really, really happy with. One of the goals was to not have an individual equation for each site, to have something more universal, and it came out really well. One thing I wanted to point out from this is the raw data set for those 30 sites is the reason we spent the 3rd winter doing work was to fill out the upper part of this curve. The upper part, here we did not have a lot of stuff in the very high specific conductance, very high chloride. We did not have a lot of data. And so that 3rd winter was used to fill that out. Another hope for this is that it can be used by others. That was another one of our goals of having one equation instead of an equation for each site, is that others in the region, especially in the region, TR64 does talk about where this is most appropriate to use, and some of the statistics we use to develop the equations as well. But the hope is others can do less grab sampling, maybe a few to make sure your site, is fitted by one of our equations. And then you can move ahead and do more conductance sampling. That equipment is not nearly as expensive and pretty robust. It really handled the winters well. I want to show you a couple of things from our TR63. This is our chloride trends analysis, not only our data, but historically. And that work is in progress, but wanted to show you a few things to keep it fresh. So this is a neat graph. So this is basically each of our 40 sites that we had a regression equation for. So all our conductance data converted to chloride and then averaged for each site. So this is the average at each of our 40 sites that we had relationships for conductance to chloride, and compared to urban land use. So the x-axis is urban land use for that contributing drainage area to that site versus mean chloride levels. Please note the mean chloride levels, that's a log scale along the y-axis, but this relationship is pretty powerful. It's with an r-squared of 0.94. That's a really good fit, a surprisingly good fit. And this might be helpful for us as we think about how are we going to grow in the future? How might we, if we continue with status quo, might chloride levels increase with increased impervious surface? Another example of the data out of TR63. This is again that Little Muskego Lake where we saw the very high conductance levels. This is the data we've gathered over time. So this goes back to 1963, I believe, and the different colors. This is different data points are the different sources of the data. So we've compiled it all. This has been a tremendous effort because there's been duplicative data in the various data sets. We spent a lot of time cleaning up this data set, but you can see our data set is in the far right in the green. Also want to point out the filled triangles are surface, close to the surface, less than 20 feet deep. And the ones that are open triangles upside down are deeper samples. You can see our data set had quite a bit of deeper samples that actually had higher chloride levels and in the 250 milligram per liter range. So in 1963, Little Muskego Lake was maybe 20 milligrams per liter in the lake. Looks like kind of a kink about 1995, slow creep and then an increasing level of chloride over time. To our 200, 250 in the data set we saw. So we're pulling this together for multiple lakes and our stream locations as well, both historic and our data set. Last technical report I want to talk about is TR 67, the legal and policy considerations for the management of chloride. This was meant to be kind of a toolbox. We didn't recommend any one of these strategies. Oh, and this effort was led by the Marquette University Law School team, led by Professor Striffling and 2 of his students. So thanks to them, it definitely is a good document to give us kind of what are our tools, especially as municipalities, to potentially manage chloride moving forward. And I won't talk about all these. Allison, and I was going to talk about limiting liability, but Allison did a really great job at discussing that. We discussed a lot of the same issues. We've heard often from our private contractors that the reason they overspread salt is due to that slip and fall liability. But there's other strategies as well. Water quality trading. In our state, we're predominantly doing that. We are doing that for phosphorus. Could that be something that could be considered for chlorides? Chloride alternatives have their own set of problems. We still need to de-ice, especially in the winter. So some of the other ones like beet juice and urea have other issues that are different, but they're not necessarily better. They just bring a different problem to the table. But those are discussed, as well as some of these other. We could directly regulate for chloride. We could definitely informational strategies or help. Very important piece to just let people know what they should be doing at their homes or businesses. And some of the other ideas. A really great document. It's completed as well and on our webpage. So I'm going to skip over talking about the Green Snow Pro because Allison did a great job with that. So just a few more points, next steps for us. So we still have 3 technical reports in progress. I showed you examples of the chloride conditions and trends, and the other 2, the mass balance analysis for chloride we are working on right now, as well as we're still gathering state-of-the-art for chloride management, for water softening, for potentially treatment at either our water plants or our wastewater plants for de-icing, et cetera. Those are still in progress. So those are written to a very technical audience. That's our vision. And then the planning report, PR 57, will summarize as needed from those technical reports, and then also be written to a more public audience. And then we'll also look at alternative scenarios, future conditions, and recommendations. And again, you can find all this information on our website, either at this link or just looking at the chloride study on our website. So with that, I'm going to stop sharing because that's all I have. And where is that? Oh.
Thank you both to Allison and Laura for your presentations today. And I will add in, if anyone has a question, whether you want to type it into the chat or the Q&A, you can also use the raise hand function, and we can take questions via voice as well. So we did have one question come in so far earlier in the presentation asking, what is the change in salt use since 2018? So over the last 6 years.
So I can take that. The graph that I had shown was national salt use, and I do not have a data point for national salt use in the last 5 years, 6 years, 6 winters. I can say that in Wisconsin, we have seen some really significant reductions in salt use at both the state level and a lot of municipalities, counties, cities have shared salt use data, and we're seeing some decreasing trends. Like the city of Madison, for example, cut salt use by about 40%. It's about the same in Walworth County, and that's kind of like the last 5-ish years relative to the most recent 5 years. So trying to also account for, winter severity plays a role in that, right? I would remind everybody that, we don't have great data, much of any data. I know Laura tried to gather it on what's going down on the private side. And again, some of our like smaller municipalities don't necessarily track that information, what's going down at people's homes. We don't know. But the fact that last winter was very much like winter light throughout the state meant that like on our state highway systems, we put down about half as much salt as we do in an average winter.
Awesome, thank you. I'm not seeing any other questions in the chat or Q&A.
I want to throw one note in there because I know, Laura, you just mentioned like beet juice as an alternative, and I think it kind of deserves some clarification for people, because sometimes it's thrown around there just this idea, well, beet juice is an alternative in and of itself, but sugars really are not an alternative to salt. The sugars from beet juice are used as an additive, most commonly in salt brine. So there are a number of products that use sugars from beets or molasses. Some of them have names that remind us they come from beets, like beet heat or geomelt are another egg-based product. They tend to have other chlorides in them in addition to the sugars. But sugars, when added to brine or added to brine that's added to granular salt, help that stick in place. And they also prevent refreeze from happening. But we can't just put like straight beet juice down on the roads as an alternative. There was for a while a push to use beet juice to pre-treat rock salt, and municipalities who did that are like, whoa, like what are we doing? This is not good. And all the gunk in beet juice just does a number on their pumps. And there's also a lot of issues. Anytime that you add a sugar, microbes want to break that down, right? That's part of the reason it can be a problem in our water, but it's also a problem in storage tanks, right? So when people are using sugars, they have to use anti-foaming agents. I don't want to say they aren't good. Sugars actually can cut down the corrosivity of salt, but they are used as an additive in brine as an additive to salt, I should say, salt brine additive.
Thank you. Well, seeing no other questions coming through, once again, thank you both for presenting today. And I did want to plug one reminder to everyone. There are some additional opportunities for webinars this week for Stormwater Week. There's one happening tomorrow evening from 5:30 to 6:30 p.m. Pond problems, solutions, and reporting. And there is one happening at this same time over the noon lunch hour on Thursday, is stormwater treated. So hopefully we will see some of you at those other webinars. And I'll once again send out the link to this recorded webinar to your emails. So if you want to watch again or share the link with someone else who might be interested, you should have that in your inbox in just a few days. And that will also, again, have Allison and Laura's information. So I'm sure if you do have any questions that come up in the future, I'm sure that they'd be more than willing to answer those if you contact them.
Thank you, Kelly.
All right, thank you.
Thanks, everybody.
Thank you both, and everyone have a good rest of your day.